Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. What is the major product of this reaction? What is this reaction? You can see this allene type moiety reacting with bromine in carbon tetrachloride. I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now student, if you look at this molecule, you'll say, sir, it's a pretty complicated example, tough question. Frankly speaking, it's very easy. I shall teach at the end the shortcut, but now let's discuss about the basic chemistry. Now, what is the major product in these reaction? So it is bromine in carbon tetrachloride. CCl4 is solvent, bromine is the reagent. Remember, when bromine react with alkene, so it undergo induced dipole polarization. Means, so in presence of another molecule of bromine, these bromine polarizes in this way, because we know each bromine atom have 3 lone pairs in its outermost shell. So if it has 3 lone pairs, so this lone pair can repel each other. In order to reduce this repulsion, what it does, it induces some amount of charge separation. So you can see here there is negative, there is delta positive. So by combination, very weak attraction force. This is. Now if you look at these delta positive bromine can behave as electron deficient or electrophile. So slightly electron deficient, I agree, but still. And remember, compared to bromine-bromine bond, carbon-bromine bond is relatively stable. So that's why this reaction also done. Now if you look at this allene, it is actually called cumulative double bond. What do I mean? So by the way, this double bond and this double bond, they are not in conjugation. They are 90-degree perpendicular. But if you say this case, this is butadiene, here this is conjugated. Okay, so remember, this is conjugated alkene, it's cumulated alkene. Now these will react with this bromine reagent. So what will happen? Actually, if you look at these double bonds can behave as isolated alkene. As I told, they are not in conjugation. So one of them can react with bromine and result a 3-member ring, which we called as bridge bromonium ion as intermediate. By the way, if you have a query to learn more about this, I've already uploaded dedicated lecture. You may visit for further learning. So you can say, sir, there are 2 bonds, 2 pi bonds, 1 and 2. So the both of the pi bond can undergo addition. Yes, both have equal probability. You may think like that. This is bromine carbon tetrachloride. This is bromine carbon tetrachloride. But one thing I want to say, student, in a chemical reaction, there may be infinite ways, infinite options for the chemical reaction to happen, but out of them only those will take place which is associated with lowest energy of activation. Okay, in which case the energy of activation is lowest? Obviously, which pathway is associated with less energy? Now, in this context, you may think that, okay, sir, here this oxygen will attack this bridge bromonium ion. By the way, before going to that, let me tell you little description. So there is a double bond, means you can think like that. If it react with this bromine, so this bromine act as electrophile and this double bond act as nucleophile. So it attacks and this bromine leaves. So what it produces? So there is a pi bond. So there is one sigma bond formation with bromine and neighboring carbon will have a positive charge, and obviously this neighboring bromine is remain as bromonium, means negative charge, anion or bromide ion. So in the next phase, what happened? There are 3 lone pair on this bromine, so one of them can attack here and result a 3-member ring, which we called as bridge bromonium ion. You may think like that this bromine formed a bridge between the 2 carbon. Now you may ask one question, that sir, instead of that this bromine can attack there. Possible, but remember whatever I have written, this bridge bromonium ion formation is actually a intramolecular reaction. And remember, intramolecular reactions are always favored over intermolecular counterpart. So that's why first bridge bromonium, second this bromine will attack from the back side and anti-addition. I'll not go. Now you may think one question, that sir, three-member ring formation because of this bridge bromonium ion. We have studied previously that three-member ring is associated with ring strength. Yes, but in this case the ring strength factor is little less. Why? Look at this bromine. This bromine atom is big size. So if its size is bigger, so you can expect the ring strength is relatively less. So that is another point that why it forms. Okay, I'm not saying that it doesn't have any strain. It has significant strain. Not only that, bromine is electronegative atom carrying positive charge. It is not that much stable. So it is produced as an intermediate. Okay. Now, so this bridge bromonium ion in both cases formed. Now, this oxygen lone pair will behave as NGP. Means it will act as a nucleophile and it participate in neighboring group participation. So these oxygen will attack. Now, by the way, in this case, student, I suggest you count from here. 1, 2, this carbon 3. By the way, these are branch. Do not get confused. And these are CH3, not CH2. Methylene could be the part of chain. I mean here, methylene part of chain. CH3 cannot be part of chain. It is the branch. Now 1, 2, 3, 4, 5, 6. Now always one statement, 6-member ring formation is associated with more stability. Why? Because remember, 6-member ring has less angle strength. Do not get confused that 6-member means this one. No. In this case, you may think, sir, it's a 120-degree angle. There must be ring strength. If angle is 120 degree, sp3 hybridization. 6-member rings actually look like this. So from there, you can clearly understand the angle strength is minimum. Means the angle is sp3 angle, I mean 109.5. Now, if you think, sir, there is actually a double bond. Yes, I agree, some amount of strain is there, but still, this will be relatively more stable. Now, next point. So here, this is since 1, 2, 3, 4, 5, 6. So the nucleophilic attack will happen here and it will open. Now you may ask, sir, why not this one? So in this case, this is 1, 2, 3, 4, 5. So in this case, if the nucleophilic attack take place by this oxygen lone pair also, it will result 5-member ring. So only here 5-member ring formation possible. And here there are both chance 5 or 6-member. As I told that 6-member ring is relatively more stable due to lesser angle strength. This 6-member ring will be produced. Okay, now how this happens? So here you can expect, okay sir, actually I have drawn this way such that your understanding is better. So it will attack because these carbon and these oxygen are close together. So proper conformational orientation could be attended. So it can open up. See, bromine is carrying a positive charge deficiency. So if the bond pair goes on bromine, it will be neutralized. Now student, whenever you do any ring formation, I suggest write everything as it is. It helps. So, and if possible, do numbering 1, 2, 3, 4, 5, 6. So it's a 6-member ring, everything as it is. Now in the next stage, whatever modification you want to do. So in the next phase, what will happen? See, this oxygen atom was neutral and carrying a lone pair. Now these neutral atom gave its electron density to this carbon atom. So obviously, it will have a deficiency which is designated by this positive charge. Now positive charge on a electronegative oxygen atom, it's not that much stable, it's not permanently stable. So what will happen? Next step, it will release this H plus and form this cyclic ether. Okay, this cyclic ether, now one thing, oxygen attached to this chiral carbon, and actually I'll not say chiral here, it's true that it's asymmetric, but I cannot say which one is top, which one is bottom. The chirality part I cannot say, that's why it is not mentioned. There is one hydrogen here, and next phase this bromine attached to this sp2 hybridized carbon. So this is your answer. Now here one point I have written Thrope-Ingold effect. What is that? Or Jem dimethyl effect or angle compression. What is that? Student, remember, if this is actually a ring formation reaction, and if there are someone or something which motivates the ring formation then? Now if you look at this carbon here, it's attached to 2 methyl group. Okay, these 2 methyl groups are, student, helping the ring formation. This factor is called Thorpe-Ingold effect and gem dialkyl effect or gem dimethyl effect. Why? Because of this 2 methyl group, they are attached to the same carbon. So that's why it's called gem dimethyl. And because of this, they create some amount of steric effect. So if you form a rings, okay, these repulsion to some extent could be minimized. So you may consider, so this is actually a motivation for this ring formation. Yes, I agree ring formation take place, but this is actually a motivation. Now why this motivation needed? Actually, if you look at ring formation is associated with loss of entropy. Molecule prefers to maintain higher entropy. So ring formation has a negative point. So that in order to motivate the molecule further, these 2 methyls are introduced. This is called Thorpe-Ingold effect. Remember, it may be helpful. And it is actually angle compression. Why? Because of this angle try to reduce, and that's why it attacks and resulted this. So this is a very important terminology, if possible, remember. So what is the major product here? So obviously this oxygen, bromine, by the way, it is actually a addition reaction, if I say. So when bridge bromonium ion means actually bromine addition 1-2 fashion. In this case, compared to the second Br minus, what this oxygen did the nucleophilic attack. So the position, relative position of these oxygen and bromine should be 1-2. So if you look at this option B in this context, option A is illogical, option C, okay, fine, option D, it is also illogical. So actually, according to discussion, option B is the answer. Now, if you get this question in your exam hall, how can you solve it? Student, do not get confused. In this question, there is a tricks. Now, in this exam hall, do this 3. By the way, do not think this is a part of the ring CH3. It will be branch. So it's a 1, 2, 3, 4, 5, 6. And look at the question. All are 6 member. So from this question, you understand that, sir, this oxygen will attack here. Point number 1. Second point, if here bromine carbon tetrachloride, so bridge bromonium ion formation will be observed on this bond. So if this oxygen attacks here, then bromine will be here, it is guarantee. It is 1, 2 and this position. Now just draw it in properly, or if you think, okay sir, fine, these I understand, where oxygen will attach, that carbon have a methyl and hydrogen. Methyl and obviously hydrogen not mentioned, it is there. Only this option. You don't need to think. Now if you say, sir, I'm confused, how can I get? Oxygen attacks, after that CH2. Okay, and where it attacks methyl, look at, it's a dimethyl. How? Dummy option. Now there will be 1 double bond remaining. Okay, bromine I have not mentioned excess, so 1 double bond will remain. What is there? Is it there? No, gone. And if you look at here, it's a bromine addition 1-2 fashion. So what is this? It's also a dummy option. So if you think that way also, if you do not know exact chemistry of allene, etc., so and 6 member, 5 member, which will be produced, just look at the option. Option is telling 6 member reaction will produce this, so option B is the right answer. It's a easy, student, but this, in order to develop this common sense, you need to study. Okay, so this is the overall discussion. I believe this video will be useful, but one information before ending. Remember students, such kind of molecule has one kind of chirality. It is called axial chirality. Okay, we'll discuss in some other video about details, but remember, that's why I have mentioned this is top side. Actually this molecule, if you look at cumulated double bond, so this is above the plane, this is below the plane, and these hydrogen and these alkyl group on the plane. So this is actually a chiral molecule and it has axial chirality. Okay, so this is the end of the discussion. I believe this video will be useful. Thanks for watching, and if you really consider the content of my channel is worthy, then please help this channel to grow. And regarding the logo of my channel, please read this part, your doubt will be clear. So see you in my next video. Bye bye.